We're going to skip chapter 3 and we'll come back to that towards the end of the class. But right now we're going to look at chapter 4, which is called scatterplots and correlations. So we're going to be adding a new graph and a new statistic to what we already know. So there are 2 pre-quizzes available for this chapter. And then as far as Excel goes, you do want to download that data analysis package. So there are directions on Canvas. And if you go to pages, you should see those directions, as well as there's a link on the chapter 4 and chapter 5 pages. And we won't need those data analysis packages, I don't think, until chapter 5, but now is a good time to think about that and get those on there. They're free and they should only take you a minute or 2 to download, as long as the directions work out just fine for you. If you run into any questions, let me know. But let's go ahead and look at this new graph. So we're looking at something called a scatter plot. So scatter plots are really a great way to picture relationships. So consider maybe the relationship between a child's IQ score and their reading test score. Or is there a relationship between a person's height and weight? Scatter plots help us answer questions such as, how does the fuel consumption change as car speed increases? So is there an optimal speed to drive that'll get you the best miles per gallon? Do baseball games that score more runs sell more tickets to their games? Do students who score higher on their SAT test have a higher GPA in college? And if so, can we use SAT scores to predict college GPAs? These are kind of questions that we can address or start to look at by using scatter plots. Can we estimate a person's percent body fat better using either their waist or their wrist size? So which one is going to be a better predictor? So we do have an example of a scatter plot here on the right. So this scatter plot, they took people's age and how much money they made in a year. So we can look over here, maybe at these 20-year-olds. They're kind of the first dots on here. So it looks like we have a 20-year-old that made maybe $1,400, another that made $1,500. And it looks like maybe one that even made $2,500. So kind of a variety of pay scales in there. And so when I look at this scatter plot, I don't really see much of a pattern. It doesn't say to me, the older you get, the more money you're going to make. And so we might think that that's the case, but looking at the data, we don't see that supported here. So let's look at the formal definition of a scatter plot. A scatter plot shows the relationship between 2 quantitative variables that are measured for each person or each individual. So we're still sticking with quantitative variables here, but now we're taking one person and we're going to do 2 measurements on them. So the scatter plot allows us to see patterns, trends, relationships, and outliers. And each point on there is one subject or one person with 2 pieces of data collected for them. So maybe one person's height and weight, for example. The location of the point depends on the value of the 2 variables or data for that subject. So the scatter plot we have here does actually have a pattern to it, and this is Old Faithful, which is a geyser, and they're looking at eruptions. So let me circle one of these points here. So this point that's circled here, the way that I read this, it says that the geyser went off for about 3 minutes. And then it took maybe about 64 minutes for the next geyser to go off. So we measured 2 things, how long it went off for, and then how long until the next one happened.